Okay, here in the next part of the experiment, we want to look at several different compounds and their solubilities in different materials. Because remember, that's the whole point, is to be able to use the difference in solubilities to separate things. So we have 3 different compounds that we're looking at here. We have ethyl 4-amino benzoate. It's a white powder, not going to look very exciting there. We have benzoic acid, another white powder. And then we have naphthalene, also a white powder. You can see the structures there in the lab. So I've gone ahead and pre-filled my 12 test tubes here. And what I want to do is I want to test the solubility of each one of these compounds against water, 5% hydrochloric acid, 5% sodium hydroxide, and 5% dichloromethane. So I'm going to go ahead and fill these now. I've pre-labeled them all. So my first column is going to be the water. So I'm going to put in about 1 milliliter of water, or we'll do about 2 mils each time. So put that in. Okay, so we've got our water in here. Next that we're going to put in is the 5% hydrochloric acid. Okay, so we'll go ahead and start putting that in. Okay, these transfer pipettes hold a little over 1 milliliter, so need a couple shots of this. All right, next is 5% sodium hydroxide. So we'll try that with each of our 3 solutes. Now some of these can take a little while to dissolve, so we'll check on them. Okay, now finally, the organic solvent that we're going to use here is the dichloromethane or methylene chloride. So go ahead and add that. Okay. Now we need to mix each one of these. And so here's a place where having a lab partner sometimes is helpful. But I'm here on my own today. Okay. So we're just going to go through. Wonderfully exciting. Ooh, we're starting to get a result already. Okay, so we'll come back and we'll run through all of these, make sure that you have the data you need. All right, we're halfway there. Mix, mix, mix. Mix, mix. I didn't get quite as much solvent in that one. I'm going to add a little bit more to it. Leaky pipettes today. Okay, so what I've done now is I've gone through and I've mixed all of my solutions and I've let them sit for... All right, so let's look at the results of our solubility tests. I'm going to go ahead and go across the top of the column, top row here, and you'll need to record this data in the question that's coming up here. So when we looked at the first one here, so what we're looking at is the overall solubility here in different solvents of the ethyl 4-amino benzoate. So in water, you can hopefully see there's a lot still floating in here. Got a lot in the crystals, insoluble. Next one to look at is with the hydrochloric acid, and everything has dissolved. So soluble for the hydrochloric acid. The sodium hydroxide, oh, definitely not soluble. You can see a bunch on the sides here, some floating in there. And then the dichloromethane, soluble. Okay, so we had soluble in the HCl and the dichloromethane. Next one we're going to look at is the benzoic acid. Benzoic acid in water, not soluble. Big old chunk of it on the bottom there. Then we have benzoic acid in HCl, also not soluble. There's a chunk on the bottom, and we have a couple pieces floating in there. Then we have benzoic acid with sodium hydroxide, soluble. And so there's, everywhere where I've mixed it, it has dissolved, so that one's soluble. And then we have the methylene chloride, also soluble. Okay? So the benzoic acid was soluble in the sodium hydroxide and the dichloromethane. And then last but not least, we have naphthalene, very strong smelling. It's what's in mothballs. And so we look at that, completely insoluble in water. All right? It's an organic compound, not necessarily surprising. It is, doesn't look very soluble, right? I got big chunks here in the HCl, so also not soluble in HCl. Sodium hydroxide, same thing, big chunks, not soluble. Then the dichloromethane, soluble, all right? So all of these were soluble in the organic solvent, and then depending upon the structure, what we could see is some different things happening for our aqueous solutions. So for the pure water, none of them were soluble. But then we were able to affect the solubility of some of them by adding either acid or base. And that's the foundation that we're going to use in the next part of the experiment.